Hello again. This is the third installment of Chapter 1, dealing with chemical formulas and chemical equations. So basically saying, reviewing of how to write a chemical formula of a compound and how to balance chemical equations. So first type of compound we'll talk about, review, is ionic formulas, which is made up of a metal and a non-metal. It's called ionic because they come from ions. So you have a metal that is a positive ion called a cation, and you have a non-metal could be a polyatomic that contains a negative charge, which is an anion. There is one polyatomic that is a cation, which is ammonium, NH4+. We'll get to that as well. Basically what happens is you drop and swap, we call it. Basically the charges, the positive and negative, go away, and you swap numbers to make them the subscripts. So here's your handy dandy periodic table. Majority of your elements are metals, which are going to be on the left hand side. So you have the staircase, which have these yellow ones called the metalloids. And everything to the left are metals. So everything's going to be positive on the left hand side of that staircase. That means the right of the staircase is your nonmetals, which are your negative charge particles. Sometimes they do become positive, but that's another story later on in the course. So +1 is your first family, called the alkali metals. +2 is your second family, called the alkali earth metals. They're positive because they lose an electron, and if it's 1, they lose 1. If it's 2, they lose 2 electrons. These are your various oxidation values, so they call them various because they vary. There's only a few elements that have just one oxidation number, and that would be zinc +2, silver is +1, and chromium is +2 as well. Then you get +3 because majority of those are your metals like aluminum and gallium, and then you get a varying oxidation number, carbon being -4, tin and lead vary, usually +4 or +2. And then you get -3 for your nitrogen group, -2 for your oxygen group. Fluorine is -1, that's the halogens, and 0 for your noble gases, and that's why they don't react, because they don't become ions. They're stable no matter what. And we'll get to that in chapter 3. Here are some polyatomic ions. You have a list in your packet, but you can see ammonium is your +1 charge, NH4. Polyatomic just means it has many atoms. So it has more than just one type of atom. So ammonium is made up of nitrogen and hydrogen, where carbonate is made up of carbon and hydrogen and oxygen. Hydrogen carbonate is hydrogen, carbon, and oxygen, and so forth. You have hydroxide, nitrate, phosphate, and sulfate with different charges. So you can see carbonate's -2, hydrogen carbonate is -1, hydroxide's -1, nitrate's -1, phosphate's -3, and sulfate is -2, or 2 negative. So write the formula for each ionic compound. Magnesium chloride is +2 for magnesium, -1 for chlorine because it's in the halogen group, and what we do is drop and swap. So that 2, you drop the sign, so the plus and minus don't matter. The 2 goes to chlorine, that's why it's Cl2, and the 1 goes to Mg, that's why it's just Mg. Sodium nitrate, they're both +1 and -1, so they cancel out, so no swapping or anything like that. So it's just Na-NO3. Iron 3 bromide, so you can see iron is an oxidation number varying, it could be 2 or 3. So in this case it's +3. So the 3 goes to bromine, so you swap, and the 1 goes to Fe, so you get FeBr3. Silver oxide, silver is a transition metal, but it's always +1. So there's no Roman numeral, as you can see. So the 1 goes to oxygen, you don't write the 1. The 2 from oxygen goes to silver, so you get Ag2O. So like I said, three major transition metals don't have variant oxidation: silver, cadmium, and zinc. Silver is +1, cadmium and zinc are +2. So write the name. The name is just like reverse. You just gotta remember that if it's a transition metal, it is going to have a Roman numeral unless it is zinc, cadmium, or silver. So in ZnCl2, it's zinc and it's chlorine. Now zinc is always +2, so you don't need the Roman numeral. So it's just zinc chloride. B, we have lithium, and you have a polyatomic because it's made up of two different elements, CO3. So you have to go to your list and know that CO3 is carbonate. So it's just lithium carbonate. No Roman numeral because lithium is not a transition metal. MeNO2 is manganese. This one's a little tricky because you have to know that oxygen is -2. That means manganese had to be 4 because it gets reduced to MnO2. And then you have CaSO4, again a polyatomic, has 3 different elements. So it's calcium, you have to look up what SO4 is, and that's sulfate, which eventually you should know by heart. Oxygen ions are compound ions with oxygen in it. You can see it has AT in it, ATE for some Roman numeral or some transition metals. So SO4 is sulfate ion, PO4 is a phosphate ion. Here we have sodium and the sulfate, so it's sodium sulfate. Here you have calcium and then the CO3, which is carbonate, so calcium carbonate. And the only one that doesn't have an ATE in it is hydroxide, and the most common base that we work with is sodium hydroxide, NaOH. Here's some more practice. You should pause and see if you can get these names. And here are your answers: sodium phosphate, ammonium sulfate, ammonium chloride, not transition metal because there's no Roman numeral, but it's not part of the transition metals, and calcium nitrate. All right, covalent bonding is dealing with nonmetals. And it just depends on how many electrons are needed to complete the outer shell. It follows along with the plus and the minus charges of these nonmetals. Carbon takes 4 bonds, that's why it's a -4. Nitrogen takes 3 bonds, that's why it's a -3. Oxygen is 2 bonds, that's why it's a -2. And hydrogen and halogens are 1 bond, that's why it's a plus or -1. So with covalent compounds, you use prefixes. So you have to know that mono is 1, 2 is di, 3 is tri, 4 is tetra, and so forth all the way through 8 is octa. No mono if it's the first atom in the compound. So there's no mono carbon dioxide, it's just carbon dioxide. So it's understood that it's 1 carbon if it's the first element in the name. No need to use the periodic table. There's no drop and swap. Doesn't matter about bonding. It is what it is. It's how many of that atom, and you use prefix. So here are some examples. We have carbon tetrachloride. So carbon, there's no prefix in it, so it's 1. Tetra means 4, so it's CCl4. Dihydrogen monoxide. Oh, dangerous dihydrogen monoxide. 2 hydrogens, 1 oxygen. So you got H2O. Sulfur hexafluoride. That's the stuff that makes your voice turn deeper. Unlike helium makes it squeakier, lighter. So sulfur is 1, hexa is 6, so it's SF6. And fluorine dioxide, 1 fluorine, 2 oxygen, so it's FO2. Same concept for naming. You just got to look at how many of that element you have and use the prefix. Again, no mono for the first element if it's 1. So for A, sulfur pentabromide. B, NO3, B, nitrogen trioxide. H2S, dihydrogen monosulfide. And xenon octafluoride. Alright, balancing equations. So when you're balancing equations, you gotta remember the atoms of each element must be the same value on both sides of the equation, hence the word balancing. So for example, H2 plus O2 yields 2H2O. You have the reactants of hydrogen and the products of water. You have the yield sign. You have coefficients. So coefficients help you balance the reaction. So even if it's missing a number, it's not there, it's always understood to be 1. So we got liquid ethanol, C2H5OH, burns with oxygen to make a combustion reaction, and you make water and CO2. So how many carbons do we have? We have 2, we have 6 hydrogens, 5 plus 1, and we have 3 oxygens on the left-hand side. And the right-hand side, you have 1 carbon, 2 hydrogens, and 3 oxygens. Gotta be careful with oxygen, it's on both of the elements, or actually oxygen in everything. So that's going to be the hardest one to balance. So you always leave that to the end, even though it's balanced right now. So either going to balance carbon or hydrogen. So we're going to do carbon first, put a 2 in front of CO2 because that means the carbon will change to a 2. It also changes oxygen to a 5 because it's 2 times 2 because there's 2 CO2s. So that's 4 plus the 1 from oxygen makes it 5. Then we go to hydrogen. Put a 3 in front of hydrogen, that makes it turn into a 6. So that's good. But it also changes oxygen because again, once you change one thing, oxygen's in everything, so oxygen's going to change. So we had 4 from the CO2. We have 3 more, so that gives you 7. So carbon's balanced, hydrogen's balanced, oxygen is not balanced. So we put a 3 in front of the O2 because we already have an extra oxygen from the ethanol. So that means 1 plus whatever needs to get 7. So 1 plus 6 gives us 7. And we have a balanced reaction. Everything is the same. 2 carbons, 6 hydrogens, and 7 oxygens. Done. Alright, here are your homework questions for this lecture. It's on page 12 in your textbook if you want to look at that. You do need to know the formula for iron 2 chloride and hydrogen gas. You gotta remember hydrogen and hydrochloric acid. Hydrogen gas is diatomic, so it's H2. You also need to know the formula for aluminum hydroxide and aluminum oxide. You should know what water is. And letter C, octane, just like what we just did with ethanol, it makes carbon dioxide and water. Alright, next topic is net ionic equations. So net ionic equations, they like to use this question a lot in AICE. So what happens in a net ionic is that you have ions that are only participating in the reaction. So the other ones are called a spectator ion because they're not doing anything. They're doing no part. So the ionic equation just involves the things that change. So for example, we have zinc solid, it's important to note solid, copper sulfate AQ, that means aqueous in solution, zinc sulfate aqueous, and copper solid. So notice zinc goes from solid to AQ, so that changes. Copper goes from AQ to solid, that changes. but sulfate is AQ and sulfate is AQ. So sulfate does not change. So break apart into the ions. So you can see here, we separated the aqueous solution, copper and sulfate and zinc and sulfate. You cross out the spectator, so sulfate doesn't matter because there's no change in state. They stay in AQ. And then you bring down everything else to get the balanced equation. Double check the balancing and everything's 1 to 1, so that's good. The worked out example on page 13 is a good example. Number 15. Again, look at states. Magnesium goes from S to AQ, so that should be in the equation. H goes from AQ to G, so that should be, but chlorine goes from AQ to AQ. So chlorine is a spectator ion. So your equation should only have Mg and H in it. So you should get H plus 1, because hydrogen is a plus 1 charge, and Mg is a 2 plus charge, and it's balanced because it has 2 hydrogens to balance out the H2. So again, notice chlorine is not in the equation because it's a spectator ion. Alright, here's page number 14, page 14. You can try to practice this one. You can pause it and see if you get the right answer. So if you balance it out, you should get 2H plus 2OH and 2 waters, which can get reduced down to H plus OH minus and H2O. So you notice that you have a bunch of AQs. This is the acid-base reaction called a neutralization reaction because you have an acid and a base. And you always make water and a salt. Water is the one that is causing this state of change. It goes from AQ to liquid. So that means H and OH are the only ones that are going to participate in the reaction. That means sulfate and sodium are your spectator ions. Alright, so just like a neutralization reaction, you have a precipitation reaction. They're both similar. Basically, you're going to make a solid. That's what precipitate means. It comes out of solution. We abbreviate precipitate to PPT. So here's an example. We have zinc chloride and sodium hydroxide, and you make zinc hydroxide. That's the S is the precipitate, and then the other solution is NaCl. So it's also called a double replacement reaction because the metals are going to flip-flop between the anions. Now the spectator ion, this one's a little easier to do for the net ionic or the ionic equation. The easiest part is to work backwards. You start with the solid, okay, and that's zinc hydroxide, and then you have to figure out what you need to make zinc hydroxide. So you need zinc, charge is +2, always, and hydroxide, charge is -1, always, and balance it out, you get the ionic equation. So here we have, again, another precipitation reaction or double replacement. You start with the solid, so you bring down FeOH2, and then what you need from that is the Fe. Look at the charge, it is +2 because sulfate is -2. You need hydroxide because that's what FeOH is, and again hydroxide is -1, so you need 2 of them. That comes from the Na, and you're done. Last example, it's checkup number 15, page 14. Again, pause it, see if you get the right answer. So what you do is look at the solid. In this case, PbI2 is the solid because it has S. Bring that down. So that means lead and iodine are what's participating in the reaction. So you need lead. Look for the charge. It's +2 because you do reverse drop and swap. And then you do iodine. Iodine's always -1. Make sure you bring down the 2 to balance it out, and you get the ionic equation. Alright, that's the end for balancing reactions. It's a lot to do. So if you have any questions, let me know.